Hi, welcome to Easy Math. My name is Zishan, and today we're going to address questions from baseline worksheet. I have seen students have difficulty in a few questions, so I'm going to solve only those questions and explain them here. The first set of questions that I'm going to deal with is about quadratic equations and algebra. And then we're going to go on to the other parts in the worksheet. Well, the first one we have it's about a simple quadratic equation where x minus 3 whole square is a 4 by 25. The only mistake that I've seen people do here is this sign. They don't put up a plus minus there. There are two possibilities. If x minus 3 square is a 4 by 25, x minus 3 can be a positive square root of 4 by 25 and a negative square root of 4 by 25. Positive 2 by 5 or a negative 2 by 5 is what you get on x minus 3. And that is why x is supposed to be these two answers. And of course, these two can be solved. Either you can use the calculator or a simple simplification where you take the LCM of, I think, 5. That's what you do. 17 by 5 is what you get. And for the same, this is going to turn out to be a 13 by 5. That was one part A. One part B is about 4 minus x square is a 12. Again, a probability of you doing a mistake where you go 4 minus x is a square root of 12. Well, it's going to be a plus minus square root of 12. And of course, from there on, negative x comes out to be a plus minus square root of 12 minus a 4. And x is going to be a 4 plus minus square root of 12. And you can use your calculator to do it. Or one thing I would like to say, root 12 can be written as root 4 into 3, which is a root 4 into root over 3, which is a 2 root 3. Okay, that's just about root over 12. Okay, the other one part C, you're going to have to look at that. One part C, you're going to have to multiply the brackets. When you do that, x minus 1 into x plus 3 comes out to be a x squared plus a 2x minus a 3 equals 9. And from there you go, take the 9 to the other side, it becomes a x squared plus 2x minus 12. And of course, you can solve it from there. Splitting the middle term, if it's difficult, you can actually use the quadratic formula, which is x equals to minus b plus minus square root of b square minus 4ac divided by 2a. Okay, now how do you find the values of a, b, and c? Well, you compare the quadratic you have with ax squared plus bx plus c equal to 0. A in this case is a 1, B in this case is a 2, and C is a negative 12. And you substitute the values here in the quadratic formula and get the answers. Okay, the same thing you want to do with the part D, same as in the two things should be multiplied. X squared plus 4x equals 17. X squared plus 4x minus 17 is what you get. And from there on, you can use the quadratic formula. Okay, let's move on to the second question. 2x squared minus 7x plus 4 equals 0. Now, here A is a 2, B is a minus 7, and C is a 4. You can actually split the middle term also. When you know A is a 2, B is a minus 7, C is a 4, you can use quadratic formula. But if you want to use splitting the middle term here, remember 2 into 4 is supposed to be an 8. And I don't see any kind of splitting the middle term happening here. 8, there are factors of 8 which are 8 and 1, which can be subtracted to give you a 7. I don't see anything like that happening here. So let's just use the formula here and check. Minus b plus minus square root of b square minus 4ac divided by 2a. Well, remember, b is a minus 7. So a common mistake is simply writing a 7 there. No, it's a negative 7 plus minus root over minus 7 square minus a 4 into a into c divided by 2 into a. Now, that's a 7 plus minus square root of 49 minus a 16 into 2, 32 divided by 4. Yes, there was no splitting the middle term possible here. And from there, I think you can do it on the calculator. Well, this is an interesting question where you're given 2 times y minus 1 square minus a 7 times y minus 1 plus a 4 equal to 0. And the quadratic, you were looking for the values of y, by the way, here. The quadratic that you did in the previous part of the same question was 2x square minus 7x plus 4. Well, you have obtained values of x here. That's over there. Well, what I want you to notice is that y minus 1 has replaced the x there. What you got for x here should be the value you get for y minus 1 there. Meaning, if x was a 7 plus a root over 17 by a 4, here y minus will come out to be the y minus 1 will come out to be the same value by a 4, and that is why y will come out to be a 7 plus root 17 by 4 plus a 1. I remember that the value that we got earlier were they were a little different. Let me just check if I am right here. You go b equals, okay, minus 7 plus minus root over b square minus 4ac 16 into 2, that's a 32, 32 and 49 minus 32. So that's a 17. Yeah. Okay. Yeah. Yeah. And of course, there are decimal values that you can put up here on root 17. And y minus 1 will come out to be this only because x came out to be that same value in the previous quadratic, and y is going to be plus 1 that. Yes, that's how you do it for the 2 part B. Now, for the third question, I've got a very simple formula here, a very simple approach. If x equals negative b by a is a root of the quadratic or any polynomial, ax plus b is a factor. Well, now that I see in the part A of the third question that x equals to 2 is a root, well, that makes me write that x minus 2 is a factor. And if x equals 6 by 7 is a factor, well, 7x minus 6, x equals 6 by 7 is a root, which means 7x minus 6 is also a factor. The thing is, I compared 6 by 7 with a minus b by a. I caught a b equals minus 6 and a equals to 7. We have a minus b equals 6, b equals minus 6, and a equals 7. And that is why we get ax plus b as 7x minus 6 as one of the factors. And now that you have two factors of the quadratic, x minus 2 into 7x minus 6 is the quadratic. You open up the brackets by multiplying the factors, you'll get yourself the quadratic that they're looking for in the form ax square plus bx plus c. I'm leaving it here. That's for you to do. Now we go part B. X equals to 1 by 2 and x equals to negative 2 by 3. Again, comparing both of them by a minus b by a, I see b is a minus 1 and a is a 2. B is a 2 and a is a 3. Well, from the first root, I get a factor of 2x minus 1. And from the second one, I get a factor of 3x plus 2. Well, multiply these two, you get yourself the quadratic that they're looking for in the form ax square plus bx plus c. When you multiply these two, 2x with 2x gives you a 6x square. 2x with 2 gives you a 4x minus a 3x minus a 2. 6x square plus x minus 2. That's the quadratic in the form ax square plus bx plus c. That's all. Okay. So that was third question. And the idea is if x equals to minus b by a is a root, ax plus b is a factor. Okay. And for your practice, you can try x equals to minus 5 by 7, and x equals to 3 by, let's take a 4, and create a quadratic in the form ax square plus bx plus c equal to 0 for these two roots. That's for you to do after you have been through the video. Okay, now we go, look at the fourth one. Well, for the fourth question, there is one little thing in math that we have been doing for a good while, but we don't realize it's it's a thing. I'll tell you. Let's look at the LCM when I add a 1 by 3 and a 1 by 15. Well, the LCM will come out to be a 15. Okay, let's look at it when we have a 1 by 2 and a 1 by, let's say, 18 maybe. The LCM will come out to be an 18. Okay. And what would be the factors? What would be the numbers that you're going to put up here? Well, 15 divided by 3, it's a 5. 5 multiplied by 1 is a 5. 15 divided by 15 is a 1. 1 multiplied by 1 is a 1. And you're going to get a 6 by 15. Same scene here. 18 is going to be divided by the 2. You get a 9. 9 multiplies with the 1. You get a 9. 18 divides by 18. You get a 1. 1 multiplies with that 1. You get a 1. That's 10 divided by 18. Or a simple 5 by 9 is the simplest form it can be. Okay. Now, what I want to show here is 1 by 2x plus 1 and x plus 3 divided by 2x square minus 5x minus 3 equals 2. Well, just like you have a 3 and a 15, where 15 is a 3 multiplied by 5, you have a 2 and a 2 multiplied by 9. You have something similar happening between these two. 1 divided by 2x plus 1 plus x plus 3 divided by 2x plus 1 into x minus 3 is what it is if you pay attention. When you factorize this quadratic, you're going to get that it's the product of 2x plus 1 and x minus 3. Just like you have a 3 and a 3 into 5, 2x plus 1 and a 2x plus 1 into x minus 3. Well, the LCM, like it was a 15 here, the LCM is going to be 2x plus 1 into x minus 3. And now this divided by that will just be a x minus 3 multiplied by a 1, x minus 3, plus this divided by that whole thing is just a 1. They're literally the same things. That 1 multiplied by x plus 3 equals 2. Now, minus 3 and plus 3, they cancel out. You get a 2x divided by 2x plus 1 into x minus 3 equals 2. And 2x is going to be 2 times 2x plus 1 into x minus 3. Now you can bring the quadratic back here by multiplying these two and then manipulate to create a quadratic of the form ax square plus bx plus c equals 0 and then solve. The only trick here is about knowing that 2x square minus 5x minus 3 is a 2x plus 1 into x minus 3. And the LCM, if there is a 2x plus 1 here and a 2x plus 1 there, will just be the product of these two. And that's why there's gonna be x minus 3 and x plus 3 up there. That's all. Okay. Here, in the part B, you have got a x divided by x plus 4 minus 3 divided by x minus 1. Well, it's the same as there being a 1 by 5 and a 1 by 7. Well, the LCM would be a 35. Similarly, the LCM here is going to be just the product of the two, x plus 4 and x minus 1. Well, this multiplies with the x, this multiplies with the 3, this whole thing, and you get a x times x minus 1, negative 3 times x plus 4, and you can simplify and bring that down to a single fraction. That's for you to do later. Okay, now comes the part which is actually difficult for everybody. And everybody has their own, everybody does it their own way, but I'm going to try to do it uh, in a way I have been teaching. Uh, there are some of these on the website also. We're talking about easymath.com. You can log into this website, get into IGCSE math tab, where you can see me explain this quadratic and the form that you want to reach with this quadratic in the question. Okay, so you go look at negative x square plus a 5x minus a 4. The idea here is to take a negative out common from the first two terms, put them in a bracket. By the way, these two are supposed to be in a bracket always. In the bracket there, you're going to add two terms. Look at the coefficient of 5. You're going to add a plus 5 by 2 square and a minus 5 by 2 square. That's completing the square method. And then a minus 4, just like it was. Now, 1, 2, and 3. These three of them are going to reduce into a perfect square. Put a bracket, x, there's a minus, and there's a 5 by 2 square. That's what these three will reduce into. And there's a minus 25 by 4 minus a 4. Now you can open up this bracket, minus x minus 2, x minus 5 by 2 square. The negative with that negative brings you a plus 25 by 4 minus a 4. And there, these two you can do on the calculator. 4 common, 25 minus 16 minus of x minus 5 by 2 square plus 25 minus 16 is a 9 by 4. And there it is. The form they were looking for, negative of x minus p square plus a q. There it is. Okay. Now that was completing the square form. The nicest thing about completing the square form is it lets you know about the coordinates of the vertex of the quadratic. See, if there is a x minus 5 by 2 in the bracket there, equate that to a 0, x comes out to be a 5 by 2. Well, that is the x coordinate of the vertex. Okay, if this is to be equated to a 0, x comes out to be a 5 by 2, that is the x coordinate of the vertex. And also, if this thing is a 0, what remains is the y coordinate of the vertex. Well, the vertex is going to be 5 by 2, comma, a 9 by 4 for this particular quadratic. Now that you've got the vertex, the part B is going to be easy to do. They ask you to sketch the graph. Okay. For sketching of the graph, always remember 1, 2, 3, and 4 things. First is about the x-intercepts, then y-intercepts, and then vertex, and then the shape. These 4 things you're going to have to keep in mind while you're sketching it. X-intercepts are to be obtained by substituting a y equal to 0 and solving for x. Y-intercepts are supposed to be obtained by substituting x equal to 0 into the quadratic and obtaining the y value of it, of the quadratic. Same here, substitute a y equal to 0 in the quadratic, obtain x, which is literally solve the quadratic. You literally have to solve the quadratic here. And vertex, I just told you, if you have the square form of it, obtaining the vertex coordinates, it's not difficult. I'll tell you another way of finding out the vertex. And then the shape, it depends on the value of a. If a is positive, the quadratic looks like that. If a is negative, the quadratic is supposed to look like that. Okay, let's do the first part, which is about x-intercepts. negative x square plus 5x minus a 4. That's your quadratic. Equate that y to a 0. Split the middle term. You get a 4x plus x minus a 4 equals 0. Take a negative x common out and a 1 out common equals 0. You get a 1 minus x into x minus 4 is equal to 0. Well, x is a 1, x is a 4. Those are your x-intercepts. Now that you have the x-intercepts, finding out the vertex is simple. You can add the two x values and divide by a 2. 1 plus 4 divided by a 2. You get a 2.5. Well, that is the x of the vertex, x coordinate of the vertex, 2.5. Obtaining the y from there, you need to substitute a 2.5 into the quadratic. You're bound to get the y coordinate, which I already know is a 9 by 4 for this one, because we have done this already. Okay. Now let's do the y-intercept. Y-intercept is supposed to be when you substitute x equal to 0, the y value, and then you go substitute a 0 in place of x here, comes out to be a minus 4. Well, minus 4 with a 0, that's your y-intercept. Let's look at the vertex. Well, vertex we have already obtained, 5 by 2 and a 9 by 4. And the shape, since I see the a value is negative here, see, ax square plus bx plus c equal to 0 is supposed to be the general form of a quadratic. What we're given is a negative x square plus 5x minus 4. A is a minus 1. If you can see, it's negative, and that is why the quadratic is going to be upside down. It's going to be like that. Well, the vertex is at a 5 by 2, comma a 9 by 4. The y-intercept is a, y-intercept is a minus 4. Okay, let us see. Yeah, so thing is, for you to have a x-intercept of 1 and a 4, the vertex being right in between these two, y-intercept is going to be somewhere there, a minus 4. The shape is going to be something of this kind. Well, of course, it's not that sharp turning there. So yeah, y equals to minus 4, x-intercepts of 1 and 4, and that's a 5 by 2, comma 9 by 4, your vertex. That's about it. That's your quadratic sketching. Well, if you want, let's give you a few quadratics to sketch. Let's have a 2x square plus a 5x minus a 7 equal to y. That's one of the quadratics. I would like you to do a times x plus b square plus a c kind of a form on it first, obtain the coordinates of the vertex, then sketch the quadratic. Let's give you another one. We can go do a negative x square plus a 5x minus a 7 maybe. Let me just check once if it is really something that you would want to do. Well, let's not do a minus 7. Instead, let's do a plus 7 here. That's better. And these two questions, again, bring them to a times x plus b square plus a c form, and then sketch them out. That's for your practice. Do it later. And then we're going to move on to the word problems in the worksheet. We're looking at question number 6 now. And you're supposed to be looking at, okay, there are two numbers. Okay, there are the difference between the reciprocals of two consecutive positive integers. Well, if I assume one of the positive integer to be x, obviously the one next to it, the one right next to it is going to be a x plus 1. If the first one is assumed to be x, its reciprocal is going to be a 1 by x. And for this one, it's going to be a 1 by x plus 1. That's saying that the difference between the two reciprocals is a 1 by 12. Well, there it is. 1 by x minus 1 by x plus 1 is a 1 by 12. Remember, if x is a smaller number, 1 by x is going to be a larger number. It's right the opposite of it. It's the reciprocal. If these two are related in this way, x is smaller than x plus 1, then 1 by x is going to be larger than 1 by x plus 1. Subtract these two. Larger minus the smaller should be a positive 1 by 12. And that is how you know the expression that you have created for the question is correct. Now, x into x plus 1 would be the LCM. Cross multiply is a 1 by 12. And of course, x and minus x will cancel out. 1 divided by x into x plus 1 equals 1 by 12, or a x times x plus 1 equals 12. Now you can solve it. X comes out to be a 3 or a 4, if I remember it right. That's it. Now let's look at the seventh one, the most difficult out of the whole thing. And we are talking about exchange rates here. Well, let's put up a table quickly. I'm going to put up November here and December here. Well, we can take up Singapore dollars and Australian dollars here. See, in November, if you take, look at that, X numbers of Singapore dollars, you're going to get 100 Australian dollars. Okay. In that case, 1 Singapore dollar is going to be 100 divided by X Australian dollars. And if you're looking to exchange 650 of them, 650 Singapore dollars, their Australian conversion is going to be 100 by X into 650. Okay. Comes out to be 65,000. Okay, I'll write it again. 100 divided by X into 650 comes out to be 65,000 divided by X. That's the amount of Australian dollars you're going to get in November. Let's look at December. Exchange rates are different. The thing is, if you do X minus 5 Singapore dollars, you're going to get 100 Australian dollars. Well, in that case, 1 Singapore dollar is going to be 100 divided by X minus 5 Australian dollars. And then 650 Singapore dollars are going to be 65,000 divided by X minus 5 Australian dollars. What they've said about this situation is, if he does it, if the person exchanges it in December, he would get 20 more Australian dollars than if he had exchanged it in November. What you got in December is 20 more than what you got in November. Okay. So 65,000 divided by X minus 5, the amount of Australian dollars that you got in December, 65,000 divided by X, the amount of dollars you got in November, the difference is a 20. And again, this turns out to be a quadratic. And I have explained the questions before where you had to solve fractions like these to get a quadratic, and you can do it from there. So that's the thing. You can actually post me the answers or tell me the answers you get. Let's see if you match. And from there, if you get the exchange rate, you can find out the answer for the part 2. Okay, now let's look at the 8th one. A boat travels 12 kilometers upstream and back in 1 hour and 30 minutes. If the speed of the boat in still water is X, going upstream, where you go against the current, the speed is going to be X minus 5. Why do I put a 5? Well, because they've said that the speed of the current is a 5. Plus, you're going upstream. So effective speed is going to be x minus a 5, you're going against. Going downstream, that's where you go with the stream. Your speed, effective speed, is going to be x plus 5. 12 kilometers you go upstream, 12 kilometers you go downstream. Both of them together is a 1.5 hour. That's 3 by 2 hours. Remember, if the speed is kilometer per hour, the time value that you put should also be in hours. Remember, this is coming from the formula distance divided by speed is supposed to be time. Well, time taken going upstream, time taken going downstream should both be added to a total of 3 by 2. And that's what we have done here. 12 divided by x minus 5, 12 divided by x plus 5 should be a total of 3 by 2 hours. Yes. And again, you solve it. It's fractions which can be reduced to a quadratic. And I have explained enough of those in the previous ones. Okay, that's about it for quadratics and algebra. If you want, you can practice the review exercises from the Shingley book that I have sent to some of you. If you want, you can ask me. I'll send it across. Review exercises from the Shingley book. Just do the first 5 questions. Those should be good enough for you to prepare. That's it. I'll see you. Bye-bye. And in the next video, we're going to do some other questions, which are going to be about indices. We're going to do 13, 14, and so on. Okay.